Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking good care of yourself. My name is Anoop. Welcome to yet another amazing channel of Vedantu. So this would be a channel wherein we'll be doing a lot of topics regarding CBSE 9th, 10th as well as ICSE physics as well. So I'll be a physics master teacher over here, and let me introduce myself before we get started. So my name is Anoop Sir. I'm a master teacher of science here at Vedantu. I've been teaching for the past couple of years now. I've taught and mentored thousands of kids all over the country. So that's a little bit about myself. We'll get to know each other a little better as the days go by. So a very warm welcome to all of you guys out there. So with that said, people, the topic or the chapter that we're going to start off with is this. That is nothing but motion for CBSE Class 9. All right. And the topic that we're going to talk about in today's session is basically distance, displacement, speed and velocity. That is average speed and average velocity is what we're going to talk about in today's session. So I'll start off the session with a very simple quote, something which is very close to me. And the quote goes like this, guys: there is no substitution for hard work. And I truly believe this because no matter how talented we all are, ultimately you have to put in the effort to make sure that you're getting to where you want to, and there is no work around it. There is no substitution, there's no shortcut to it. Whatever you want to do it, you have to make sure that you have to put in the work for it. Anyways, with that said, guys, let me give you an overview of what we're going to talk about in the chapters, in the sessions ahead. So we'll start with distance, displacement, average speed, average velocity. In the sessions ahead, we'll talk about acceleration, and we'll also solve some numericals regarding acceleration. We'll understand about distance and velocity time graph, and then we'll also understand the derivation of distance of the three equations of motion graphically. So these are the topics that we'll be doing in the sessions ahead. So anyways, guys, with that said, let us start with motion. All right, now here's the thing. Motion is something that you're familiar with for a very long time. Since the time that you got your senses, since the time that you start understanding how the world works, you understand what motion is. So if you were to ask a kid what motion is, he'll say that when you're moving, that's called as motion. Simple as that. So in layman term, yes, motion is moving, or any sort of movement or being moved is what is called as motion. But since you guys are in 9th grade right now, you cannot go with the same definition as the first grade student. Anyways, I think you will all agree with me. So here's how you define motion, guys. Motion is nothing but when the position of a body is changing with respect to time. That is what is called as motion. So when the position of a body is changing with respect to time, that is what is called as motion. Now, couple of terms that or terminologies that you guys are aware of is distance, displacement, speed, velocity, acceleration. These are terms that you've juggled with even in the past. Even in your 7th grade, 6th grade, 8th grade, you've studied a little bit about motion here and there. But there is still this confusion that many people have that, sir, what is the difference between distance and displacement? Now, for me, from my perspective, it might seem like a very straightforward answer, but that's not the case, guys. Now, I'm going to show you an example to help you guys understand a little better about distance and displacement. So let's start with an example, guys. So let's say that there's a kid who's walking towards a school. Very simple scenario, something that we used to do before coronavirus. Yeah. Now here's the thing. There might be different paths to get there. Whatever path that he chooses, the length of that path is called as distance. So what I'm trying to say is that, let's say that there is one path which is about 1.5 kilometers to his house. Maybe another one might be 3 kilometers. So whatever path he chooses, the length of that path, if he chooses the path which is about 3 kilometers long, then the distance is 3 kilometers. If he chooses a path which is 1.5 kilometers long, which comparatively is the most shorter one, which means that his distance covered is 1.5 kilometers. So whatever path he chooses, the length of that path is what is called as distance. But displacement is a little different. So here's what displacement is, guys. So let's say that the kid initial position, or the kid is starting from a point, let's say X. He's starting at a point X. And he reaches his house, his final position. So at whatever time he reaches his house, I'll take this Y. Whatever is the difference between the initial position and the final position, that is what is called as displacement. So what is displacement? Displacement is nothing but the difference between the starting point and the ending point. In other words, you can see it as the shortest distance between two different points. That is what is called as displacement. Now, I know that many of you guys are still confused about it. So let's take another example. Don't worry, guys. All right. Let's say that you're, in a race. You're in a running race. You're in a cross-country race. So you decide you're going to go the full distance. So let's say that you took a path. This is the prescribed path, and you go all the way from here to here, and then like take a U-turn and then come back here. So that's the that is the path you're traveling. Now the path that you took, that is a distance. The path that you took is the distance. Now you start from this point. So that is your initial position. You're starting from that particular point. And then you reach this point. So this is your final point. So that is your start. This is your starting point. And this is your final point or finale, the final position. The difference between these 2 points, the starting point and the final point, is what is called as displacement. So in comparison, between these 2 points, let me just take another color so that you guys can see it very clearly, because so this is 1 point, this is 1 point. So you start from here and go all the way till here, right? That's the path that you're choosing. Now, the difference between these 2 points, the start point and the end point, is what is called as displacement. So if you just think about it, when you compare these 2 points, this is the shortest distance traveled. This is the shortest distance between those 2 points. So displacement can be defined as the shortest distance traveled, or you can say that the shortest distance between the 2 points, or you can say that it is the initial position minus the, final position minus the initial position. That is difference between the end point and the start point. That is what is called as displacement. So in other words, guys, just to put everything into perspective, the total distance is calculated by the path that the object takes. So whatever the length of the path is, that is a distance. Displacement is the difference between the start point and the final or the end point. Done, done, done. That's it. So that is about distance and displacement, guys. Now, here's the thing. When you talk about distance and displacement, there are some few concepts that you have to understand. One is path dependency. Now, what do I mean by this? Here's the thing, people. Distance is path dependent. What do I mean by that? Let's say that I have to go from here to here, point A to point B. Simple. Now, I have 3 ways to reach there. I have this one way. This is called as distance 1. This is distance 2. I can take that path, or I can even take this path as well. So 3 different paths to reach the same point. All right. Now, whichever path I take, whatever is the distance, let's say that this distance is about 10 kilometers. Let's say that this is about 5 kilometers. Let's say that this is about 20 kilometers. So what I'm trying to say is that distance is the path taken, the length of the path or the path taken by the object. So if the person chooses to go from path number 1, then he would have covered a distance of 10 kilometers. If he chooses to go by path number 2, he would have covered a distance of 5 kilometers. If he chooses to go by path number 3, he would have covered a distance of 20 kilometers. Now, displacement is not path dependent. Like I told you, what is displacement? The final position minus the initial position, or this difference between the start point and the end point, is what is displacement. So here's the thing. No matter which path he takes, let's say that the boy takes this path. All right. He goes all the way till here and finally reaches here. Very simple. Now, he starts off from the same point. He starts off from A itself and he ends up in B. No matter what path he takes, even if he takes, let's say he takes path number 3, he would have gone all this way and reached the exact same point. There's no difference. He's starting from A and ending at B. So the final position is B in all the 3 cases, and the initial position in all the 3 cases was also A. So what do I mean by this? Displacement is basically the final position minus the initial position, and it is not dependent on path, because no matter what path he takes, displacement in all the 3 cases is going to be the exact same. There's not going to be any change in displacement in all the 3 cases, because the final position and the initial position in all the 3 cases is the exact same. Alright guys, so that is what I mean by path dependency. So distance is path dependent. Whatever path I take, that length is distance, and displacement is nothing but the final position minus the initial position. So it is completely path independent. So no matter what path I take, it's all about the difference between the final and the initial point. Simple as that. Alright guys. So that said, now let's talk about direction, because that is also a very important factor when it comes to understanding about distance and displacement. So here's the thing, people. Distance does not depend on direction. No matter what direction you go, it is just the path taken. So you don't consider direction at all. But displacement, on the other hand, is path or direction dependent. So generally, if you've ever seen a number line before, a number line basically goes like this, right? You have on the right hand side, you have positive terms. On the left hand side, you have negative terms. On the top, you have positive terms. On the bottom, you have the negative terms. So when you draw a number line, this is how you do it. In the same way, guys, you can also represent displacement as also the same. So if the direction of the body is towards the east side or towards the right hand side, it is considered to be positive. If the direction of the body is towards the west side or towards the left hand side, that is considered to be negative. If the direction of the body is towards the top or towards north, that is considered to be negative, positive. And if the direction of the body is towards the south or down, then you can say that the direction of the body is said to be negative. So displacement is dependent on the direction as well. So you can say that it, when the direction or when the displacement is in the positive direction, then you can say that the displacement is also positive. If the displacement is in the negative direction, then you can say that the displacement is negative. Simple as that. All right. So that is about the direction as well, guys. So remember this. Just remember the number line. It is something that you're very much familiar with. So right hand side or east is positive, left hand side or west is negative, north or up is positive, south or bottom is considered to be negative. As simple as that. All right, now here's the thing. Displacement, in conclusion, has both magnitude as well as direction. That means it has a value. With that, it also depends on the direction as well. So you can come to the conclusion that displacement is a vector quantity because it depends on both direction as well as the magnitude. Whereas distance, on the other hand, is a scalar quantity. Why is it scalar? Because there is no direction involved. Only we consider the magnitude. There's no direction at all. No matter what direction you take, distance is going to be the same. But displacement depends on the direction as well as magnitude. So we consider it as a vector quantity. That's it, people. Anyways, more about scalars and vectors. You'll study that in your higher grades as well. So don't worry, you're in safe hands. Anyways, so that's it, people. Let's do a couple of questions. Now, I want all of you guys to do the questions with me. So what I want you people to do is that as soon as I put up the question, pause the video for a second, take down the question, try to solve it by yourself. I'll also give you about 10-15 seconds. That's pretty much it. So you can quickly pause the video, take down the question and try to solve it by yourself. And after that 10-15 seconds, I'll also solve it for you people. So here's the question, guys. There's a guy called Scott who travels 5 miles towards north and then goes towards west 3 miles before coming straight back south 2 miles. So the question is, what is his distance traveled? One of the most simplest question. He travels 5 miles north, 3 miles west and 2 miles towards south. So what is the distance? Is it 10 miles, 8 miles, 6 miles or 7 miles? Now again, guys, pause the video right here, solve the question and let me know the answer in the comment section below. All right. Anyways, in the meantime, let me try to solve it for you people. So here's the thing. I'm going to draw this out for you people. All right. So there's this guy called Scott. Yeah, my drawings are excellent. All right. Anyways, so he goes north 5 miles. So I'm just gonna start off. Okay, yeah. Let me just do that. So north, he goes 5 miles north. Then he goes west 3 miles. And then he goes 2 miles south. So I'm just gonna write down the values over here. So 5 miles over here, 3 miles over here, and 2 miles over here as well. Now, what is distance? Distance is the path traveled or the length of the path taken by the body. So what is the length of the path? 5 plus 3 plus 2. Simple as that, because he has taken that path, right? He has chosen that path. He has traveled so much, the length of the path, in other words. So if you just write it down, what do we get? Distance is equal to 5 plus 3 plus 2, which is how much? 5 plus 3 is 8, 8 plus 2 is 10. So 10 miles would be the answer. Simple as that. So that, my friends, is one of the most simplest questions that you're going to get. That is, the answer for this question is 10 miles. That is a distance traveled by Scott. All right, so moving on to the second question now. So second question goes like this. A car travels along a straight road 100 meters east and then 50 meters west. Find the distance as well as the displacement of the car. So you're given four options. Option A is distance is 100 meters and the displacement is 150 meters. Option B is distance is 150 meters and the displacement is 50 meters. Option C, distance 150 meters, displacement is 100 meters. Option D, distance is 50 meters and the displacement is 150 meters. So you're supposed to find out the distance as well as displacement. So car moves along east 100 meters and then west another 50 meters as well. So you're supposed to find out the distance as well as displacement. So once again, people, pause the video and do try out the question by yourself. In the meantime, I'll try to solve it for you people. All right, so here we go, guys. Let me just draw a simple looking car first. And then, yeah. All right, so yeah, it goes all the way to 100 meters. So that's 100 meters. And then again comes back another 50 meters. So I'll just draw that with maybe a different shade or different color. So he comes back again another 50 meters. So he goes 100 meters towards east and then 50 meters towards west. So what is the distance traveled? So what is the distance traveled? You guys know the answer to that. Distance is basically the path taken. In this case, it's 100 meters towards east and then again 50 meters towards west. So that is 100 plus 50. So that makes it 150 meters. So that is the distance traveled. Talk about displacement. So here, if you check the displacement, the initial and the final position of the body, the initial position of the car is over here and the final position of the car is right here. So if you check what is the difference between where it started and where it is ended, so let's just put that over here to the displacement. Displacement is equal to the final position minus the initial position. Now final position with respect to the initial. So first of all, initial position is 0 because the car is basically standing still. He's in the state of rest. Whereas if you talk about the final position, on the other hand, the final position, let me just make that small correction. It's not supposed to be plus, it's supposed to be minus. So yes, so the final position, however, is going to be 50. Why 50? Because from the point that he has started, what is the position of the car? It has come back first it went 100 meters, then again came back 50 meters. So what is the final position of the car from the start point? It's 50 meters. So final position of the car is 50. So 50 minus 0, that makes the displacement to be 50 meters. So distance is 150 meters, whereas displacement on the other hand is 150 meters. So that makes it option number B to be the right answer because distance is 150 and the displacement is 50 meters. Simple, guys. All right. With that said, moving on to the next question. Now this question is something which looks a little complicated, but then it's actually quite easy. So here we go. An object moves along a grid through a point A, B, C, D, E, and F. All right. So let's cover some distance. You're supposed to find out what the distance is. Also, you're supposed to find out the magnitude of displacement. You're supposed to find out the magnitude as well as the distance. Now, here's the thing. The hint is that each and every unit of that or that grid is about 0.5 kilometers. So you're supposed to find out what is the total distance traveled, and you're also supposed to find out what is the displacement of that particular object. All right. So to calculate the distance, it's actually pretty simple. So you have to find out what is the distance from A to B, and then B to C, then C to D, then D to E, and then E to F as well. Very simple. So each and every grid is 0.5 kilometers. So just calculate how many grids are there between A to B, then B to C, then C to D, D to E, and then E to F. So here A to B, there are 1, 2, 3, 4, 5, 6 grids. So 6 into 0.5 would give you what is the distance between A to B. In the same way, find for B to C as well. So there are 6 grids. So that is 6 into 0.5. That makes it 3 kilometers if I'm not wrong. And between C and B, there are 2 grids, which makes it 0.5 into 2. So that's 1 kilometer between C and B. And between C and D, there are 3 grids. So that is 3 into 0.5. That's 1.5 kilometers. And between C to D, E to D, there is 0.5 kilometers difference between them. And for the final one also, it's 0.5 kilometers itself. 0.5 kilometers for the last one as well. So total distance is basically add up all of these values. 0.5 plus 0.5 plus 1.5 plus 1 plus 3. So that's 3 plus 1 is 4, 4.5. Then we have 4 plus 1 is 5.5 plus 6. So that will be around 6.5 kilometers. So distance traveled, the total distance would be equal to 6.5 kilometers. Now to talk about displacement. Here's the thing is, displacement is basically what is the initial position and the final position of the object. So you're basically supposed to find out what is this distance. Okay, suppose find out what is that distance between A to F. What is that distance? That is what you're supposed to find out. Now you cannot directly find this out because the grids are not exactly proper. It's not something that you can use the grids. That's not exactly correct. So what you can do is use Pythagoras theorem to actually find out the answer for this question. Now again guys, you have to pause the video and try to find this out, but yes, I'm going ahead with the topic because it's a session at the end of the day. So here's the thing. So what I'm going to do is that I'm just going to draw these two, I'm going to join these two lines. I'll call this as G. All right, for now, I'm just going to call this G. So I'm going to use Pythagoras theorem. I'm going to take another sheet of paper and try to solve it for you people. So these are the options that is given. You have distance is 6.5 kilometers, displacement is 0 kilometers, distance is 2.5, displacement is 2.5, distance is 6.5, displacement is 2.5, distance is 6.5, and the displacement as well is 6.5 kilometers. So I'm just going to draw it out for you guys. So I'm just going to take the triangle alone. So this is A, and this is F, and this is G. So between, I'm supposed to find out what is the value of AF. Between F and G, let me just go back and see what is the value of F and G. So between F and G, there are 3 grids, 1, 2, and 3 grids. So 3 into 0.5, that gives me 1.5 kilometers. So between F and G, the distance is 1.5 kilometers. Between A and G, if I were to check, there's 1 grid, 2 grid, 3 grid, and 4 grid. So 4 into 0.5 would give me a distance of 2 kilometers, right? 4 into 0.5 is 2 kilometers. So I know the value of of FG and also AG. I'm supposed to find out what is the value of AF. So how do you find that out? Very simple, Pythagoras theorem. AF square is equal to FG square plus AG square, as simple as that. So that would give me it's 1.5 square plus 2 square is equal to AF square. So AF square 1.5 square I think is around 2.25 if I'm not wrong. I'm not really okay. I think it's 2.45, and 2 square is 4. So add that up, that'll give me 6.25. AF square is equal to 6.25. Now to find out AF is equal to root of 6.25. That would give me a value of, I think, around, if I'm not wrong, if I find out the value, that'll be around, I think, 2.5 if I'm not wrong. So it'll be around 2.5 kilometers. So that'll be the answer is. So the distance or the displacement between A and F is basically 2.5 kilometers. As simple as that. So yeah, you can do the calculation. You can check out the calculation as well once. If I made any mistakes, you can let me know as well. So this is how you calculate it. You'll get the answer as 2.5 kilometers. As simple. It might look like a very big problem, but it's actually a pretty simple one. Anyways, so with that said, guys, now let us do another problem. Here's the third question, guys. Here's the fourth question, sorry. Tino runs exactly 3 laps around a 200-meter track. You have to find out what is the displacement. Is it 100 meters, 200 meters, 0 meters, or 600 meters? So Tina runs in a circular path. So you have to find out what is the displacement in this case. Very simple. Do try it out. Again, pause the video, check out the answer for yourself, do it out, try it, and let me know what is the answer in the comment section below. However, the answer to this question would be 0. Why would it be 0 in this case? Because when a person is moving in a circular path, the thing is that the initial position and the final position is going to be the same. And because the initial and the final position is going to be the same, if you were to use the formula final minus initial position, you will get the value to be 0 because it's the same. You start from the same point and end up in the same point. So when a body or an object comes back to the place where it started off from, then the displacement would be 0 because again, initial and the final position is the same. So the displacement is going to be 0. So here also displacement would be 0. As simple as that. All right. Anyways, with that said, guys, let's move on. And now we're going to understand the next concept of this chapter, which is nothing but speed. So let's talk about speed. Here's the thing, guys. Speed is something which tells us how fast or slow an object is moving. Simple. It tells you if you're going fast or it tells you if you're going slow. Speed tells you that. But when you talk about speed, there's a little more to it as well. It's not just that, right? You can't just have it as, it's just not just how fast or slow. If you were to calculate speed, if you were to define speed in terms of physics, speed is nothing but the distance covered by the time taken. So whatever is the distance covered in a particular time given, that is what is called a speed. So if you have to write on the formula, you guys already know about it. You studied this in your 6th grade. So speed is equal to distance traveled by time taken. Simple. And the units would be, the SI unit of distance is meter and the SI unit of time is seconds. So it will be meter per second. SI unit of speed is meter per second. As simple as that. Now, one more thing about speed is that, see, you can have the same speed, but you cannot say that the motion is the same. I'll tell you that. For example, guys, let's say there are two people walking, right? One person is walking towards the east, and let's say your friend is walking towards the west. Now, both of them are supposed to cover a distance of 30 meters, all right? And they're both covering the same exact distance in 10 meters. It's a 10 seconds. So 30 meters in 10 seconds sounds good. They're pretty fast enough. So if you were to calculate the speed in both the cases, so speed is equal to distance by time, where S is speed, D is distance, and T is time. So distance is 30 and time is 10. So 0, 0 gets cancelled. So it'll be 3 meter per second. So both of them are traveling at a speed of 3 meter per second. So yes, both of them have the same speed, but can you say that the motion is also the same? The speed is same. Yes, I do agree. But is the motion also the same? The fact is, no, it's not. The reason is this, guys, because there is another quantity that defines, because both of them are going in opposite direction. You're in speed, we don't consider direction because distance does not depend on direction. So we don't consider direction at all. But there is a quantity which takes into account even the direction as well as the the speed at which the person is going, and that quantity is what is called as velocity, because velocity is something which is dependent on direction as well. So how do you define velocity? Velocity is nothing but rate of change of speed in a particular direction, or you can say it as displacement by time, because displacement considers direction as well. So it's displacement by time, which is what is called as velocity. And more importantly, guys, velocity, when you talk about velocity, it is nothing but speed, but then in a defined direction, in a particular direction. That is what is called as velocity. So velocity is displacement by time, wherein if you talk about the unit, the SI unit remains the same, because displacement SI unit is also meter and time is also seconds, so it will be meter per second itself. And more importantly, velocity is a vector quantity, whereas speed is a scalar quantity. Velocity, on the other hand, is a vector quantity, because we also consider the direction of the body as well. So because of this, we can say that velocity is a quantity. So when you say that both the people are going at the same speed, it might not be that their motions are also the same, because if their motion has to be the same, then they both should be traveling in the same direction as well. So both of these, if they satisfy both the conditions, then and only then you can say that their motion is the same. Alright, guys. Anyways, with that said, now let us understand about uniform motion and non-uniform motion. So here's the thing: is uniform motion is nothing but when a body is covering equal distance at equal interval of time, you can say that the body is moving at uniform motion. For example, in this situation, the person is cycling and he's covering every 2 seconds, he's covering a distance of 4 meters. So I check what is his distance that he's covered in 2 meters, 4 meters. And if I check the time, if I check at 4th second, I see that he's covered a distance of 4 meters, another 4 more meters. So it's 8 meters. If I check his distance in maybe another 2 more seconds, that is in the 6th second, I see that his distance that he's covered is 12 meters. So at every equal interval of time, he's covering equal distance. Every 2 seconds I'm checking, I see that he's covered a distance of 4 more meters at every interval. So that kind of motion is what is called as uniform motion. And for a body to be in uniform motion, the speed obviously has to be constant. Only if he's traveling at constant speed, he'll cover equal distance at equal interval of time. So in this case, if you have to calculate the speed, distance by time, so distance is 4 meters divided by the time taken is 2 seconds, so that'll be 2 meters per second. So what I'm trying to say is that throughout his journey, he's been traveling exactly at 2 meters per second itself, and that's why he's covering equal distance at equal interval of time. On the other hand, guys, but this is not always possible, no? Because when you go out to your school, when you ride a bicycle or something, you have a lot of obstructions as well. You'll have speed bumps, you'll have people crossing the roads, you'll have traffic. All of these would lead to something called as non-uniform motion. What is non-uniform motion? Is nothing but when a body is covering unequal distance at equal interval of time, or equal distance at unequal distance at unequal interval of time. You can say it like that also, or you can say that he's covering equal distance at unequal interval of time. So whatever fact, whatever are you're comparing with, you can either take the distance, or you can take it as time, or you can take it as both: unequal distance at unequal interval of time, or unequal distance at equal interval of time, or equal distance at unequal interval of time. All of these would definitely mean the same thing, that is non-uniform motion. So all of that would mean that his speed is also varying. So in this case, if you see, he's in 4 seconds, he took 4 seconds to travel 4 meters. And then another 2 seconds, he covered another 4 more meters. And then he took another 6 seconds to cover another 4 more meters. So if you check the speed in all the 3 cases, you see this. In the first case, his speed is 4 divided by 4. Again, distance is 4, time is 4 seconds. So that's 1 meter per second. In the second half, if I check, that's his distance is 4 meters again, but his time taken is 2 seconds, so that's 2 meters per second. In the third case, if you just check, his distance again is 4 meters, but then displacement of this, the time taken is 6 seconds, so that makes it basically 2 by 3 seconds. So 2 by 3 meter per second, meter per second. So what I'm trying to say is this, guys, that you can see that his speed is constantly varying, and this would lead to the condition where he is covering unequal distance at equal interval of time, which is what is called as non-uniform motion. As simple as that. All right. Okay. With that said, guys, now here's the thing. If you were to find out the average velocity in uniform motion, it's going to be the same, because at every time interval, if I check, his speed is still going to remain as 2 meter per second itself. So his average speed throughout the entire journey is going to be 2 meter per second. But the problem with non-uniform motion is that you cannot take that, because his speed is constantly varying. I cannot just take the mean value of it. No. So to calculate the average speed, that is throughout his journey, what was his speed? If I have to check that, I can find out the average speed. So to find out the average speed, I have to basically calculate it like this, that is the total distance traveled divided by the total time taken would give me what is the average speed of that particular object. So in this case, if I have to calculate what is the total distance, that is 4 plus 6, that is 12 meters. Again, he's covered a distance of 12 meters. Time taken would be 4 plus 6 plus 2, that will be 12 seconds. So 12 divided by 12. So his average speed throughout his journey was around 1 meter per second. If you just calculate it, you'll get as 1 meter per second. So to calculate the average speed, in non-uniform motion, you have to use this particular formula, that is total distance traveled divided by total time taken. You can't just take any one random value. You cannot say that the average speed was 2 meter per second, or you cannot say that his average speed was 2 by 3 meter per second. You cannot claim that. So you have to calculate it by adding the total distance divided by total time taken. That will give you the average speed. As simple as that. Now to find out the average velocity, it's pretty much the same. In place of distance, you have displacement. So it will be total displacement divided by the total time taken would give you the average velocity. Simple as that. So average speed is total distance by total time taken. Average velocity is total displacement by total time taken. That's it, people. So with that said, guys, what we're going to do right now is we're going to do some questions. We're going to solve some questions. Now, again, guys, I want all of you guys to take a screenshot of this. If you're not aware of it already, take a screenshot of this and, utilize it for your exams as well, for your upcoming exams. With that said, we'll solve some couple of questions and try to utilize that information that we just saw and try to convert it to knowledge to the fullest extent possible. Here's the first question, guys. All right. A car travels along a straight road to the east for 100 meters in 4 seconds and then goes west for 50 meters in 1 second. Determine the average speed and average velocity. Option A is 30 meters per second is the average speed and 10 meters per second is the average velocity. Option A 15 meters per second, option B and 10 meters per second. Option C is 15 meters per second and 5 meters per second. Option D is 10 meters per second and 10 meters per second is the average velocity as well. So do try it out, guys. Again, pause the video. Let me know what is the answer, A, B, C or D. Write down the question number and write down the answer as well. Type it out in the comment section below. I'll definitely be sure to check it and let you guys know. All right. Anyways, with that said, let's get back to the question now. So a car travels along a straight road, all right, for 100 meters first. Awesome. Now he again travels east. So I'm just gonna east would be basically he travels backwards again 50 meters. All right. So I'm supposed to find out what is the average speed as well as what is the average velocity. So let's start with average speed. So average speed is what? Total distance divided by total time taken. Total distance divided by total time. Awesome. Total distance is what? 100 plus 50 because he traveled all the way to 100 meters in east and then again came back 50 meters west. So total distance is 100 plus 50. Plus 50, and total time taken is what? He took 4 seconds to go the 100 meters and then again 1 more second to come back. So that's 4 plus 1, right? So that's 150 divided by 5. 5 threes are 15, so that's 30 meter per second, right? That's his average speed. So I found out the average speed. Now to find out the average velocity. Now to find out the average velocity, you have to find out what is the total displacement by total time taken. Now in this case, the displacement. What is the displacement? So if he's starting from this position, moving all the way to here and then coming back to this place. So his final position is over here. If his starting position, the distance is 0, then the final position, the distance is going to be 50. Simple as that. So what is the average velocity? Let me just write it over here. So I'm just going to write it over here itself. Average velocity is equal to, I'm just going to rub this part out so that, you know, I hope you guys have taken it down. So I'm just going to erase it so that I can have some space to write this. So I'm just going to erase this. I hope you guys understood that. So I'll just write down the value alone over there. So what did I write? It was basically 150 divided by 50. So that's 30 meter per second, right? So yeah, I'll just erase this as well. Make way for naughty. All right, anyways. So here, so average velocity is equal to total displacement. Displacement by total time taken. Done. So displacement is 50 because again initial minus final position. Final position is 50 and initial position is 0. So 50 minus 0. Total time taken is once again 5 seconds itself. So it'll be 50 divided by 5. That gives me 10. Sorry. Okay. Calculation mistakes. Sorry people. So that'll give me 10 meter per second. 10 meter per second. Simple as that. That's it, guys. So that'll be the average velocity as well. So in conclusion, that'll be the answer, guys. Option number A would be the right answer because average speed I found it as 30 meter per second and average velocity I got as 10 meter per second. Simple as that. All right. So that's it, guys. Moving on to the next question. I hope you guys understood this. Here's the next one. A man walks 7 kilometers east in 2 hours and then 2.5 kilometers west in 1 hour. Find his average speed and average velocity for the whole journey. So your options are average speed is 3.2 km per hour and average velocity is 1.5 km per hour. Average speed is 4.2 km per hour. Velocity is 1.5 km per hour. Speed 3.2 km per hour and 3.2 km per hour is the velocity as well. Average speed is 2 km per hour and average velocity is 1.5 km per hour. Once again, people, I'll show you people, but once again, I want all of you guys to try out the question, pause the video and do try it out by yourself. So here's the question, guys. He walks 7 kilometers towards east. Yeah, that's my man. All right, 7 kilometers towards east. And then he walks another 2.5 kilometers back. So I'm just going to represent that with a different color, maybe red. So he walks 2.5 kilometers back towards west in 1 hour. So this distance is basically 2.5 kilometer. So I'm supposed to find out what is his average speed as well as average velocity. So first thing first, find out the average speed. So average speed is basically, I'm just gonna write in a different color. So average speed is equal to total distance by total time taken. Total distance by total time. I'm just gonna write it as total time right now. So total distance is 7 plus 2.5 divided by total time is 2 plus 1. Because it took 2 hours to go all the way to reach that 7 kilometers and then again 1 more hour to reach that 2.5 kilometers as well. So that makes it 9.5 divided by 3. Yeah, so that'll be around 3.1, 3.1116, maybe something like that. So that is what you're going to get as the average speed. So let me just check 3.16, I believe. So I can take it as 3.2 If you want, you can take it as round off the value and take it as 3.2. Yeah, I'll get it as 3.2 itself. Hard. Now, to find out the average velocity on the other hand, again, total displacement by total time taken. Now, in this case, displacement is basically, this is the initial position, this is the final position. So the final position is basically 7 minus 2.5. What would that be? That will give me the final position to be 4.5 if I'm not wrong. Yes, 4.5. So that will be the final position of the object. So basically you'll have to write that as 4.5 minus 0, final position minus initial position, divided by the time taken. Time taken is still going to be the same. That is 2 plus 1. So that'll be 4.5 divided by 3, which would give me, I think, around 1.166 if I'm not wrong. So if I have to round off the values, okay, I got is 1.5 and this one should be 1. Yeah, so it'll be 1.5 over here, and this would be basically 3.2 kilometer per hour, as simple as that. So I got 3.16, which you can round it off and put as 3.2 kilometer per hour. As simple as that, guys. So if you find out the average, if you find out the displacement, and if you find out the distance, you can find out the average speed as well as the average velocity. So in this case, they found out the average speed to be 3.2 kilometer per hour, which we got already, and displacement they got us 1.5 kilometer per hour, which again we got doing this calculation. So that'll be the answer, guys. So the right answer would be option number A, because option number A has these right options. Alright, guys. With that said, moving on to the next question. Here we go. If you drive, if you drive from Bengaluru to Chennai at 40 km per hour and then Chennai to Bangalore at 60 km per hour, what is your average speed for the whole journey? Is it 25 km per hour, 48 km per hour, 35 km per hour, or 50 km per hour? Now, this is a very interesting question, guys. Now, I want all of you guys to try out this question, give your best, but I'll tell you one thing, it is not 40 plus 60 divided by 2. Whoever has that thought, I know that many of you guys did. Whoever has that thought, that is not the right answer. It's not 40 plus 60 divided by 2. It's not that straightforward. You have to do a little bit of calculation. First things first. So, if you're going from Bangalore to Chennai, right, you're covering some distance. I don't know the distance, I'll take it as X. Now, here's the thing. You're going all the way till there, and you're again coming back. So you're traveling the same distance, again X. So total distance, I'll take it as 2x. Alright. So total distance, I'll take it as x plus x for now. Alright, x plus x, because I don't know the distance, so I'll take it as total distance as 2x. Alright. Now, I know that the time taken is basically, if you just think about the formula for speed is equal to distance by time. So if you have to find out the time taken, I don't know the time taken as well, because to find out the average speed, I need to know the time taken as well. Total distance by total time taken. So time taken is equal to what? Distance by speed. All right. For the first scenario, when he's traveling from Bangalore to Chennai, all right, so his speed is 40 km per hour. All right. And distance is x. So distance I'll take it as x. So time taken would be 40 time taken would be what? 1 second, people. Let me just erase that off. Time taken would be what? It'll be basically distance by time. So it'll be x by 40. All right. This is the first value that I get. All right. Now for the second one, again, I'm going to find out I'm just going to write it over here right now. I'll just erase this part out. I hope you guys understood that. So I'm going to erase this one out, and I'm going to write it over here. All right. So here we are. So for this one, for the second case, when he's traveling from Chennai to Bangalore, C stands for Chennai, B for Bangalore. I hope you guys understood that. All right, S is equal to 60 km per hour because he's traveling at a speed of 60 km per hour. All right, and then I don't know the distance again, so distance I'll take it as x again. So that'll be T is equal to x divided by 60. Now, what is average speed? Average speed is total distance traveled divided by total time taken. So total distance traveled by total time taken. So I'm just going to take another sheet so that I can, okay, let me just, I wish I could erase this off. So I'm going to do one thing. I'll just, I hope I can insert a slide. Okay, 1 second, guys, 1 second. Okay, so I'm going to do one thing. I'm going to erase the top part out. I mean, I hope you guys understood till now. So I'm just going to erase this part out, and I'm going to write it over this. So I got, remember this, that I got that time taken is x by 60 and x by 40. All right. So far, I hope you guys are clear with it. Now what I'm going to do is that I'm going to find out the average speed. All right. So I'll just erase this. So I'm just going to find out the average speed. All right. So I know that I found out that in the first case scenario, it is x by 40. In the second case scenario, it is going to be x by 60. All right, because I want to crunch everything out. All right, anyways, so to find out the average speed is equal to total distance by total time taken. Total distance by total time. Awesome. Now, total distance is x plus x. So it'll be 2x. Total time taken is x by 40 plus x by 60. Because I know time taken for the first case to go from Bangalore to Chennai is x by 40, and time taken for the second case to go from Chennai to Bangalore is x by 60. Now, find out the values of this case. If you find out the LCM, you will get the answer for this one. As simple as that case. So if you just first of all solve the denominator, so you'll get it as 60x plus 40x divided by 40 into 60. So you'll get it as 2x divided by 100x whole divided by 24, 6 was 24, so 24,000. So take 24,000 to the top. So yeah, I don't have any space to do it, so I'm going to do the calculation right here. I hope you guys are able to keep up. So I know it's a little clumsy, but yeah. So yeah, it's going to be like, okay, I'm going to take that up. So 24,000 into 2x divided by 100x. X gets cancelled, 0 gets cancelled, 0 gets cancelled. So that'll be 24 into 2. So 24 into 2 is how much? It'll be 48 kilometer per hour. Dun, 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 dun. That's a guess. So that is the answer for this question. I know it's a little, it might look a little confusing and stuff, but it's actually pretty simple. Just consider the distance to be x. Once again, go back to the video and you'll understand it better. So x, I took the distance to be x. I don't know the time taken, but I know the speed in the first case scenario was 40 km per hour. In the second case scenario was 60 km per hour. So I found out the time taken first, added the time taken, that is the total time taken, found out the distance to be 2x. Do the calculation, that is total distance by total time taken. You'll get the answer to be 48 km per hour. And that, my friends, would be the average speed of that particular person who went all the way from Bangalore to Chennai and then back to Bangalore. Yeah, because he has nothing else to do. So anyways, guys, so that is pretty much it from my side. Thank you for joining today's session. Hope you guys enjoyed it. If you did enjoy it, do not forget to give a like and subscribe the channel as well, because we'll be coming up with more such sessions as well. But before you say adieu, we have one homework for you people. Yes, we do. So here's the homework for you guys. John drove for 3 hours at a rate of 50 km per hour and for 2 hours at 60 km per hour. What was his average speed for the whole journey? This is your homework, and I want all of you guys to do this homework and put it down in the comment section below. Whoever puts down the answer the fastest, I'll put their name in the next session. I'll put their name in the start of the class before the next session starts. So do try it out and put on the answer as soon as possible. So yes, guys, and make sure that you subscribe and hit the bell icon as well, so that as soon as you get these kind of homeworks, you're able to get notified and answer these questions as well. If your name, if you want your name to be there. Anyways, so that is it from my side, guys. If you want to reach out to me, if you have any doubts regarding any of the topics that I've taught you today, you can reach out to me at anup.manoharan@vedantu.com. So until the next time we meet, take care of yourself, stay safe, stay home, and be good. Do not trouble your parents a lot. Take care of yourself, stay safe, guys. Bye bye everyone. Thank you for joining. See you all. Take care.